Okay, in this video we're going to learn how to write equations for tangent and normal lines using the derivatives that we've learned recently. Okay, so now we're going to look at how we can write the equation of a tangent line. So if we look at this picture over here, you see you have a polynomial here, or a curve, and then you have this red line here, and this red line is tangent to this curve at this point. So it just touches the curve at that point. And what's nice and important to remember is that they're going to share this point. So that point is the point of intersection between this tangent and this curve right here. So they have the same point in common. And then at just this specific point, the slope of the tangent line will also be the slope of this curve at that specific point. Okay, so now how do we write the equation of a tangent line? Well, we need to ask ourselves, how do we write the equation of any line? What things do we need to write the equation of a line? Well, to write the equation of a line, we need a point, and we need a slope. And that's true to write the equation of any line, because in our class we're going to be starting off with point-slope form, and then we can manipulate that form into another form, and so we always need these two things. So reading the question, it says find the equation of the tangent, that's what we're doing, to this curve, y equals x squared minus 3x plus 5 at this point. So they're actually telling me this point in this case, so we already have our point. But we need to be able to find the slope of that tangent line, which remember is the slope of the curve. And so we can take this equation, this curve, and we can use the derivative to find slope. So if I take the derivative of that, we're going to say the derivative of x squared is 2x, and the derivative of negative 3x is negative 3, and the derivative of 5 is just 0, so we don't have to write that. So this is our derivative, and that was in a previous video, so if you need to go back and review that, do that. But once we have the derivative, we can plug in the x value of the point here to find the slope of the tangent line, which is also the slope of the curve. So here's my x value, since our point is 3, 4. So I'm going to plug in 3 to that x, and 2 times 3 is 6, minus 3 is 3. What we get from this is the slope of the tangent line, which is also the slope of the curve at that point. Okay, so just kind of repeating that in case they phrase the questions differently. But now we have a slope and we have a point, so we can write the equation. Now we are going to use this form, which is point slope form. And that looks like this. And I always start with this form. So this is going to be y minus my y value of my point, which is 4. You can see that here. And then my slope is 3 times x minus my x value of my point, which is 3. And so this is the equation of my line. Because it didn't ask for a specific form, I can leave it like that. That's point-slope form. If it had asked me for a specific form like slope-intercept form, I could have distributed this 3 and moved the 4 and gotten it in that form. But so for us, we're going to start with point-slope form, and if we're not asked for a specific form, we're just going to leave it like that. We don't have to worry about changing it or moving anything, okay? All right, here's another example. Find the equation of the tangent again to the curve f of x equals 2 over x minus 3x at the point where x equals 1. Okay, this one's just a tad different because here they gave us the x value of the point, but not the y value. And so we're going to need that. So you can kind of do the next couple steps in whatever order you want. You could find this first, or you could find the derivative first. It doesn't matter. Let's rewrite this f of x. Remember, when we take a derivative, we don't want the x on the bottom, so we're going to rewrite this as 2x to the negative 1 minus 3x. And now I can take the derivative, and I'll say f prime of x equals negative 1 times 2 is negative 2x to the negative 2. And then the derivative of negative 3x is negative 3. And again, just to make sure it's a little bit easier to work with, you should probably rewrite this to bring this x to the bottom as x squared, so we don't have a negative exponent, minus 3. So that's my derivative, and I can go ahead and plug this x equals 1 in, so I can say f prime of 1 is negative 2 over 1 squared minus 3, and when I do that I get negative 5, and that is the slope of my tangent line. That's really important that you know that when you plug an x value into a derivative, you always get slope of the tangent line, which is also the slope of the curve at the shared point. Okay, so I have my slope, but I need my point. I need my y value over here. So to find that, I can take this equation, f of x, but I can plug 1 in, and I'm plugging it up here into my original curve. So f of 1 is equal to 2 over 1 minus 3 times 1. And when I do this math here, I get -1, and that's my y value. I'm just plugging in x to my original curve to get my y value is -1. So now I have a slope of -5, and I have the point 1 comma -1, and we're just going to go ahead and write the equation in point slope form. So y minus the y value, which is -1, equals slope times x minus the x value, which is +1. Now, I will never leave a double negative here, so we should rewrite that as y plus 1 equals -5 times x minus 1, and that's it. We can stop there unless we're asked for a specific form. Okay, so now we're going to talk about a normal line. Okay, so we're going to talk about how do we write the normal line and the relationship between the normal line and the tangent line. A normal line is perpendicular. That's huge. Perpendicular to the tangent line. So think about what perpendicular means. What does it mean for our slopes when we're talking about something that's perpendicular? It means that we have opposite, reciprocal slopes from the tangent. Basically, if I know the slope of the tangent, this normal line is going to be opposite reciprocal slope, okay? So flip the fraction, change the sign. Here's a graph so you can see what it looks like. This red graph here is my curve. That's my equation, or my original curve. The blue line is my tangent line because it just hits that curve at that one point. It just brushes it there, okay? But this green line is perpendicular, makes a right angle with my blue line, and this green line is my normal line. So that's what it would look like. And I want you to know that, again, all three of them share this point. That's a shared point between the tangent line, the normal line, and the curve, okay? All right, let's look at an example. Find the equation of the normal line to this curve at this point. Now again, I'm writing the equation of a normal line, but to write the equation of any line, any type of line, I need two things. I need a point, which I have, and I need a slope, and we're going to use the derivative to find the slope. So we're going to take the derivative. That's going to be 2x, and we're going to plug in this x value, and I get 2. But this is not the slope of the normal. This, remember, anytime we plug an x value into our derivative, we get the slope of the tangent. That's what that always gives us. And so if I know that the slope of the tangent is 2, I should be able to determine what my slope of my normal line is going to be, because it's going to be perpendicular to 2. And so the slope of the normal line is going to be -1/2. I flip the fraction, change the sign. Now I have a slope of -1/2 and a point, so we can say that the equation of our normal line is going to be y minus the y value of 2 equals the slope of my normal, which is -1/2 times x minus the x value of my point. And that's the slope of the normal. Now, if I was asked to write the slope of the tangent line, the only thing that would change in this equation would be the slope, and the slope would be 2 instead, because they share the same point. But in this case, we were asked to write the equation of the normal, and that's what this is. Okay, another example. Find the equation of the normal line to this curve when x equals -2. Okay, so I want you to take a minute and I want you to try this problem. Pause the video, try it, and then come back and check your answer with mine. Okay, so we do have this curve. So the first thing we need to do is we need a derivative. So that we should know how to do by now. So we're going to take the derivative, and this is going to give me 6x squared minus 18. That's my derivative. Now they do give me an x value that I can plug in. So I can plug in -2 for that x. And when I do that, I'm going to get, let's see, -2 squared is 4 times 6 is 24 minus 18, which is going to give me 6. That, though, you have to remember, when we plug an x value into the derivative, we always get slope of the tangent from that, okay? And we're asked for the normal. So if I know that the slope of the tangent is 6, then I should be able to determine the slope of the normal because those are perpendicular. So if the slope of the tangent is 6, the slope of the normal is going to be negative 1/6. So you need to identify that. Okay, now in order to write the equation of any line, we need a slope, which we now have because we're writing the normal, so we have this slope. And we also need a point. So my point in this case, we were given the x value of negative 2, but I do need to figure out what y value goes with this. So I'm going to take my curve here, y equals 2, and in place of that x, I'm going to plug in negative 2. Because this will allow me to find the y value that goes with this, the y coordinate of this x equals negative 2. So negative 2 cubed is negative 8 times 2 is negative 16. And then negative 18 times negative 2 is going to be a positive 36. So our y coordinate is going to be 20. So the point that we have is negative 2 comma 20. Okay, and now we can write the equation of the normal. So our normal, and it's important to remember which one you're writing because the only difference is the slopes here. So we need to make sure to use the normal slope because we want a normal line. So we're going to have y minus the y value, which was 20, equals negative 1/6 times x minus the x value, which was negative 2. And so that double negative is going to make plus. So what we would really write is y minus 20 equals negative 1/6 times x plus 2. And that would be my answer. And again, leave it in that form unless for some reason we need to do something with it or we're asked to put it in a different form. Okay? Okay, this one is just a tad different. So I'm trying to show you the different ways they can give you information. So this one says, write the equation of the normal line to the curve with gradient negative 1/4. Okay, and this one you have to be really careful about the wording because it says find the equation of the normal line to the curve with gradient negative 1/4. So what it's saying is that the normal line has a gradient of negative 1/4. So keep track of your information. The normal line has a slope of negative 1/4. That's what we know so far. We have a curve here, so we are going to take the derivative of that. And we're going to get 2x when we take the derivative of that. And we have to be careful because we don't have an x value to plug in here. Normally we get an x value, but we don't. So this represents gradient or slope of tangent. That's what I can plug in here. We don't have the slope of the tangent, we have the slope of the normal. So if the slope of the normal line is negative 1/4, then the slope of the tangent would be a positive 4. So that is what I'm allowed to plug into dy dx. So I can say 4 equals 2x. I can plug in 4 to dy dx here and set it equal to 2x, and then when I divide by 2, I get the x equals 2. That is the x value, the x coordinate of the point that the normal, the tangent, and the curve all share. Now what I do need is a y value to that. So I'm going to use my y equals x squared plus 3, and I'm going to plug in the 2 for x. And when I do that, I get 7. So my point is 2 comma 7. I'm going to use that. And since we want to write the equation of the normal line, I'm still going to use this slope of negative 1/4. I just had to have this slope of the tangent because that's what I was allowed to plug in there. Okay? So my normal line is going to have an equation of y minus the 7 for my y value equals negative 1/4, because that's the slope of the normal, times x minus 2, which is the x value. And that's my answer. If they had asked me to write the tangent, I would have just used the slope of 4 instead. Okay, so make sure you read the questions carefully and you know what pieces of information it's giving you. Okay, on these last 2 pages of your notes, I just gave you some information that's going to be really important, so you have this. But things to remember is that you can only plug in the gradient of the tangent to the dy dx. You can never put in the slope of the normal here, only the slope of the tangent, which is the same as the slope of the curve at that point, okay? And then dy dx tells us that we have a derivative. Our derivative is our formula for the gradient of a curve at any point, which is the gradient of the tangent. And you can plug in the x value where the tangent line and the curve meet. So that shared point, you can plug those x values in here to get slope. Or you can plug slope of the tangent in to solve for x. Those are really your only two options with the derivative. Last couple things, y values are always found by plugging in the x value of the coordinate to the original function, not the derivative. You don't have a y in the derivative, you have a dy dx. That's different. So you cannot plug y values into a derivative. You cannot plug x values into a derivative to get y values. When you plug an x value into a derivative, you get your slope for tangent, okay? And then you can plug x values into the derivative, and when you do that, it only gives you slope of tangent or the curve, not a y value. So I know that's a little bit repetitive, but those are things that I see people try sometimes. So you have to be very careful about that. Okay, go back and review what you need to, and I will see you in class.